This video is about our latest research on depth restoration of handheld transparent objects for human-to-robot handover. Transparent objects are common in daily life, while their optical properties pose challenges for RGB-D cameras to capture accurate depth information. For assistant robots, however, accurately perceiving handheld transparent objects is critical to effective human-robot interaction. For estimating the depth of handheld transparent objects, many challenges exist, including the lack of relevant data, the difficulty brought by hand occlusions, and the potential application in human-to-robot handover scenarios. In this work, we aim to address the aforementioned challenges. First, we create a synthetic dataset for handheld transparent objects. Second, we propose a hand-aware depth restoration method that enhances depth estimation by leveraging hand guidance. Finally, we develop and implement a pipeline for human-to-robot handover of transparent objects, demonstrating its value in real-world application. We create a synthetic dataset named TransHand 14K using Blender. To ensure the fidelity of data, we introduce a real-to-sim data generation scheme. This dataset can be used for different transparent objects perception research. Based on this dataset, we propose a hand-aware depth restoration method for estimating the depth of handheld transparent objects, which is based on constructing an implicit function from a single RGB-D image. We first extract 2D color and 3D geometry information from the RGB image and corrupted point cloud. To better utilize hand-object interactions, we introduce hand pose guidance by extracting 21 hand keypoints with a hand pose detector. These keypoints are transferred into absolute and relative hand features to model semantic and geometric information. Finally, we predict terminated position and probability of each ray-voxel pair using generated features, and restored depth is calculated by ray-wise max pooling. Experimental results show that our method outperforms existing methods, especially in terms of generalization ability to unknown objects. Qualitative evaluation also demonstrates that our method achieves superior reconstruction of object geometry in real-world scenarios. Our method achieves an inference speed of 11 frames per second, enabling real-time depth restoration, which is crucial for real-world applications. Based on the proposed depth restoration method, we develop a real-world system for human-to-robot handover. The whole handover process can be divided into 3 stages. In the first stage, we implement the proposed depth restoration model to reconstruct the point cloud of transparent objects and then generate available grasps using GraspNet. Once the optimal grasp pose is selected, the robot approaches the pre-grasp position and responds to the user's movements by tracking hand keypoints. Finally, the robot grasps the object from the user's hand and moves back to the preset terminated position. We conduct experiments on diverse transparent objects with different size and shape. The results demonstrate that our system is capable of handling commonly encountered transparent objects in daily life.